I'm David Reed with Equilibar, and I'm going to demonstrate how to control the flow rate of a non-positive displacement pump without using a sophisticated PID control loop and without using a variable frequency drive. All non-positive displacement pumps have a pressure versus flow curve that is very similar to this one. As the pressure decreases on the output of the pump, the flow rate coming out of the pump increases. The relationship of that pressure to flow is shown by this line. For every pressure, there is only one flow rate that the pump operates at. So in this case, 60 psi would provide a flow of almost 3 gallons per minute. What we'll be demonstrating in the lab is a non-positive displacement pump drawing water from a reservoir. The output pressure of the pump will go through a flow meter. Flow meter is not required. It's just there to let us know what the actual flow in the system is. The output pressure of the pump is going to be controlled by this Equilibar precision back pressure regulator. I'm going to use the back pressure regulator to put the pump at the desired point on the PV, the pressure volume curve for the pump, and I'll see that pressure on this gauge. Once I set the flow rate from the pump, that flow rate will come out of the back pressure regulator and into the system. The system here will be represented by a gate valve, and I'll modulate that gate valve to show changes in the system. Those changes will be seen on yet another gauge on the output of the back pressure regulator. Once the water comes through the system, it will return back to the reservoir. We're back out in the Equilibar engineering lab. This is our non-positive displacement pump. It's a rotary impeller centrifugal type pump. It's going to be drawing fluid from this reservoir. It's going to pump the fluid at pressure through our system. Here we have a flow meter that we've borrowed from the Equilibar engineering stores, and it's not used for the control loop. It's simply here so that we can actually see and monitor what flow rate we are controlling through the pump. Out of the flow meter, we're going to come into that Equilibar precision back pressure regulator. This is what's going to be actually controlling the flow out of the pump. The Equilibar is a 1-to-1 air pilot operated back pressure regulator, and so I'm going to be commanding or setting the pilot pressure to the Equilibar right here with this air pilot regulator. Coming out of the Equilibar, the flow goes into the system. The system here is represented by this gate valve. I'm going to be modulating this gate valve throughout the test to show that the system pressure can vary, all while the flow rate coming through the system remains unchanged. And after the fluid is done in the system, the fluid is returned to our reservoir. We've now powered up the pump and we're flowing water through the system. To set the flow rate, I'm going to adjust the pilot pressure on the Equilibar back pressure regulator. That's going to control the pressure on the output of the pump, and it's going to let me set the pump on the flow curve until I get the desired flow. Where we'll start is I'm going to run the pressure on the Equilibar up to 50 psi, and at 50 psi we're going to see that we're controlling at 4 gallons per minute of flow. And now to show the repeatability, I'm going to adjust the pilot pressure on the Equilibar back pressure regulator to get something more like 65 psi on the pump curve. That's going to give us a much lower flow rate. So I'll run this pressure up to about 65. And what we'll see is when we have 65 psi on the output of the pump, that the flow meter is at a much lower value. What's important is the repeatability of the flow control we can achieve. When I reduce the pressure back to 50 psi, the flow in the system comes right back to 4 gallons per minute through the flow meter. For our next test, we're going to demonstrate that the flow rate through the system, once it's set by the Equilibar back pressure regulator, is not affected by changes downstream in the system. I'm going to represent changes in the downstream system by this gate valve. So I'm going to modulate this gate valve, and that's going to represent a filter plugging up or valves turning on and off or other demands on the system. So right now we've set the pressure at 30 psi, and I am going to increase the restriction in the system. You can see that pressure beginning to rise. I'm going to bring that all the way up to 20 psi. And now the system restriction is at 20 psi. What we'll see is that the pressure on the pump has not changed, and the flow rate coming out of the pump is also unchanged. So today we've demonstrated how an Equilibar back pressure regulator can be used to control the flow of any non-positive displacement pump. For the purpose of today's test, I used a manually actuated regulator to provide the pilot pressure to the Equilibar. Often, people elect to use an electronic air pressure regulator to provide the pilot to the Equilibar back pressure regulator. This can help in system automation and in remote control. If you'd like to learn more, please visit us at equilibar.com.